Hi, welcome to the vBrownbag session on server-side Flash. We're going to be talking about why Flash technology is so disruptive and how it relates on the server side when you put Flash on the host. This is a passion of mine, and one reason is because I actually work for Prinix Data, and we do the host side Flash clustering and acceleration. I'm a vExpert, and I have a blog that talk about VMware projects and so forth, and also you can find me on Twitter. One reason this is a passion of mine is the fact that there's a perfect storm going on right now within the Flash area. And what's interesting is that we're starting to see Flash costs in devices fall in price. We're also seeing virtualization growth skyrocket. And what's interesting, this is a cross-connect between the latency that a lot of people are seeing as virtualization grows, and obviously the performance is affected when latency grows. This also affects the costs associated with your SAN and your performance. So we've seen a perfect storm. It's one reason why at VMworld we see a lot of storage vendors. We see a lot of different Flash solutions out there that try to tackle this latency problem and this performance problem. So there's many problems out there, but a lot of problems are focused on the storage network when it comes to latency, when it comes to read and write bottlenecks on the storage array or the storage processors, all results in a higher latency when it comes to your applications and your VMs and your workloads. So, like I said, there's many ways that you can try to solve this problem. You can add to your existing storage. That's obviously disruptive and can be costly. You could also do a rip and replace of your storage system. Again, costly and disruptive. Add network flash. You could do that, but it's a bit more of a niche use case, and it doesn't completely solve the problem. Also expensive. You could add server flash, obviously, and put your VM decays on server flash. Again, niche use case, doesn't scale, a clustering problem. And you can add an all-flash array. Flash arrays are great for data services and speed, but then you still got to deal with the network latency for storage performance. And then there's this new category that has popped up that we're starting to see, is actually adding server flash to the host and putting software on top of that to virtualize it, to give that scale-out performance, to be able to do that fault tolerance, to give the benefits that a typical storage array would give you, but be able to bring that performance to the host side and decrease IOPS and lower latency. So one reason we're seeing this as a solution is that it's a physics problem. Obviously, solving physics is it's not going to happen anytime soon because it's a law. The greater the distance between 2 points, the greater the latency. Okay, and then you also have the electron propagation delay in copper. Dealing with the insulation, the type of cabling you have, can affect the overall latency between 2 points. And then if you're using fiber, you got the refractive index of glass. Nothing can go to the speed of light because of these issues within latency, and they can affect the overall throughput and IOPS in your application. So how do you solve this? Well, obviously we're not going to solve the physics problem, so the next best thing is actually bringing, again, the performance to the compute cluster. Again, we could try to solve some of the factors, propagation delay, node delay, congestion delay, processing delay, all are factors in latency. Some of these in proper design will help. For example, if I lay out my network appropriately, maybe I'll be able to eliminate maybe some good congestion or propagation if I get the right cabling. But it's not a full fix. There's still issues that can crop up. There's too many layers in between my compute stack and my storage arrays for disk performance. So there's an interesting take on this. I've labeled this as queue stations. All the way from the compute stack cluster all the way down to your storage array, there's a lot of queuing delays. And this is one reason why, if you have an all-flash array, you can get obviously under 100 microsecond latency, which is extremely fast because flash is fast. The problem is you've got the network in between your compute and your storage. So all these queuing delays affect your overall latency. So I like to call this queuing stations because every stop, that packet, that I/O has actually got to stop at each of those locations to deal with some type of either congestion or a queue or some type of delay in the overall system. So you've got HBA queues, you got LUN queues, storage I/O control can help sit with some of this, but misconfiguration can also cause some of the latency. So you got Ethernet flow control. Another thing built into the TCP/IP stack for pausing frames during congestion. The switch fabric can introduce latency for ingress and egress situations in queues. You have target port queues, you have storage processor and OS maximums that you have to do in the storage array, and then finally you get to the disk queues itself. So obviously depending on your architecture and design, these may fluctuate a little bit, but either the case, you still have all these station stops of queuing delays that affect the overall latency of your entire system. Again, not the best scenario because we cannot solve physics. So, the disruptor, Flash, right? Well, it's not really him, it's this guy. Flash is what really solves this problem because it's extremely low latency, handles microbursting, is able to actually scale, but you have to have the proper software to do it. And you got to put that in the compute stack. So there's a new storage performance design that is on the brink of a lot of environments, and that'll help solve these, the physics, the queuing delays, your latency, your applications. And that is a performance design where it's an east-west scale instead of a north-south scale when it deals with performance. So east-west would be an example of scaling out performance. North-south would be an example of scaling out capacity. And so in this example, we have Flash in each host. We have software in each host that gives us that scalability and that clustering and allows us to utilize the horsepower of the native Flash device while destaging and using the capacity on the back end of the storage array. So we call this active I/O on this server side, and then we call the capacity tier data rest tier for your data services and so forth, because we still need that as we scale and grow. So with that, I appreciate your time. Pernix Data has a complete solution to answer this problem. You can find us at booth 2011, and I welcome your feedback. Thank you.